Hi, a very good afternoon. Welcome to another episode of Ask CyberArk, the only podcast focused on answering questions from our customers, partners, and practitioners. Today, we are honored to have Head of Research from CyberArk Labs, Mr. Lavi. Welcome, Lavi. Welcome to our podcast.
Thank you. Thank you very much. Thank you for having me.
How are you doing today?
Pretty good, pretty good. As you see, we are back to the office, at least me, so it's fun.
So I'm back in the office too. So I'm actually back in the physical office as well as you can see, our virtual office. So for today, we've got, we're very delighted to have you on board with us. And we've got a lot of questions from our customers and our prospect that has been posed to us around CyberArk Labs. So for a start, would you like to introduce yourself and introduce CyberArk Labs?
Sure. So as you mentioned, my name is Lavi, and I'm the head of security research at CyberArk Labs. And just for starters, our mission statement for CyberArk Labs is mastering security and knowing the attacker perspective very well, and doing innovation based on our knowledge of the attacker. So we have two groups doing security research, finding security holes, vulnerabilities, security gaps, and reporting those to the relevant vendors when relevant, meaning doing responsible disclosure. And after we do that, we learn about the vulnerability or the type of vulnerability or what kind of security layer we can innovate on or offer to mitigate the vulnerability itself and maybe other vulnerabilities of the same type. So yet again, the mission statement is mastering the offensive perspective and innovating based on it.
Thank you. So, since we're in the domain of research, would you be able to share with us in this new norm that we have, right? What has CyberArk Labs been seeing?
Yeah, so it's actually a very interesting question, and I think a question that the whole security community been dealing with in the last couple of months. And I think we all seen a lot of noise and backlash around communication apps. For example, Zoom. We heard a lot of discussions on the security and mainly privacy issues of the Zoom application, and I should say that they've done a lot of work. At least looking at from their side, to enhance the security and privacy practices. But to my point, I tend to think that based on what we've seen out there in the security community and based on our research, that communication application and video chat apps like Zoom and Teams become the forefront of organizations like email and Outlook been for many decades now. If an attacker could send their victims phishing emails through email, now they can also send it via those video chat apps like Teams and Zoom. And I think this is one of the most significant trends that we started to notice in this in the last couple of months. And to make my point, just to make it clear, we had one of our researchers. I'll give him credit here because he's done a great work on researching Teams. He found a vulnerability in Teams that could allow an external attacker to exfiltrate credentials and Teams data, meaning messages and files and so on sent via Teams, and compromise those, send those out from the organization. And it's not all. He also found that this vulnerability can be weaponized in a worm-like manner. So just by sending a GIF to a victim, the victim just needs to see it. So 0 clicks here, 0 clicks vulnerability. His credentials and data are exfiltrated. And the next step is for the victim to spread this malicious code via GIF to other users within the organization. And we actually created a nice chart to make it easier to understand. So as you can see on the screen, we have an attacker on the first stage sending a malicious GIF. This GIF is actually hosted on a server controlled by the attacker. So what happens is that John, our victim, when he gets this message from the attacker, he tries to authenticate to and pull the GIF from the attacker's asset, from the attacker server. And by doing so, he sends his own credentials to the server. And so this is how his credentials are compromised. And using those credentials, our attacker can just pull everything from his team's account to his own server. And as I mentioned, as you can see in stages 3 and 4, the GIF is being sent by John, actually by the attacker, but for the other user it would look like John. And those victims, like the CFO, the CEO, and Alice here, will also experience the same thing. Their credentials, the access tokens, will be sent out to the attacker together with their messages. So this is just one thing that we worked on that I think proved the point that communication apps and chat apps like Teams and Zoom are now the forefront of the organization. And I should also say that after disclosing this vulnerability to Microsoft, it was patched in just a number of days because it was a pretty significant and critical vulnerability.
Wow. So just out of curiosity, right, because we disclosed it before and they patched it in a timely manner, have we seen this attack being used in a while? Was anyone, do you know of any success with this attack?
Yeah, so this is a great question, and according to Microsoft, we haven't seen this type of attack technique being used out in the wild, but I think that the point is that the chat apps that we use today are vulnerable in many different ways. This is just one way that we found. And so although this specific vulnerability has been patched, we tend to think that because those applications are exposed externally, both to employees and to potential attackers, we might see more of those vulnerabilities coming up.
Thanks, Lavi. Well, great job to the labs for keeping us safe, right? You potentially have closed another door to what the attackers might have used to attack a much wider population. And I think we've seen this systematically. You know, wherever there's any application or platform that everyone is adopting, very quickly the attackers will be drawn to them like honey.
Definitely.
Yep. So because CyberArk Labs publish new content all the time, so just out of curiosity, what's the latest publication that Labs has been working on?
Thank you for asking. Actually, we have a lot going on in Labs, and I think one of the most significant findings that we had recently was a research focused on escalation of privileges in Windows environments. This research done by Eran Shimoni, again one of our talented researchers, found that the GPO service, the group policy service, created by Microsoft, obviously, has been vulnerable for the last decade or so for privilege escalation vulnerability. I'll just show it to you. I think it will make a lot of sense. So as you can see on the chart, we have a 7 steps attack, which again is pretty simple, and I'll try to explain as we go. First step of the attack is creating a symlink, a connection between an object to a file. It's kind of a shortcut for Windows, used by services and users to make it easier to access or run executables that are stored somewhere on the disk or remotely, for that matter. So first thing that we do is create a symlink. I should say 2 things here. First, we assume that the attacker here already have access to the machine. It's an escalation of privileges. So we assume breach, as we call it. And the second thing that I should mention here is that creating symlinks can be done by any non-privileged user. So we have a pretty low prerequisite for this kind of attack. So we created this symlink to a file that could be a DLL or executable that is protected, which is protected by ACLs, by the access list of the file or directory. So only system or local admin could access or change the file. Second step is running GPU update. The GPU update tool is a tool that, again, available for any user, any Windows user, non-privileged. And the service, the GPU update executable, triggers the GPU update from domain controller, from the Active Directory. When we trigger this service, the GPU update, the GPSVC, the service itself, goes to the domain controller and pulls whatever configuration it needs from the Active Directory. And now the interesting part happens. The GPSVC is a service that is a privileged service, runs as a system. So it can write everywhere. And because we created a symlink to a specific DLL, specifically here we used ext.dll, the GPSVC will now try to write the configuration file. It will see that we have a symlink for the printer XML here. This is the file that's being updated. And will send the updated file to the destination of the symlink. As you see here on the chart, it's the ext.dll. Now, up front, it's just a DOS denial of service attack, because we are just overriding some arbitrary file. But behind the scenes here, we can also control the content of what is being written. And we use this functionality to allow ourselves to escalate privileges. We write a malicious code that is being executed by a vulnerable application in Windows environment to be executed with system privileges. So with those 7 steps, which comes down to creating a symlink and running GPU update, we can escalate privileges to system. And Microsoft, with this vulnerability, they took their time to fix this, because GPO is a pretty complex service, so it took them, I think, about a year to fix. But it is now patched, and I think that one of the bottom lines from this research is that attackers have many opportunities to escalate privileges. I can also share with you that Iran, based on this type of attack, Iran found more than 60 vulnerabilities. So he has about 60 CVEs written on his name, leveraging this DLL hijacking symlink type of vulnerabilities. So it's pretty huge, and we took a lot of the insights from this research and implemented the mitigations into CyberArk product, and mainly the endpoint privilege manager.
Wow, 60 CVEs. That's quite a lot from an original discovery. I mean, like, who knew something like Symlink could have such a huge repercussion? So just out of curiosity, if someone would like to know more about this GPO attack, where's the best place to find out more?
So CyberArk Labs has a threat research blog, and you can find it under the CyberArk website. And we publish our research every once in a while, I think about every week or two. And this GPO and Teams research are also there. So the threat research blog is a good place to look.
So did we publish a white paper to talk in detail about this attack as well, or this vulnerability?
Yes.
Nice. So we'll post a link on this specific white paper and the blog in the description of the podcast as well. So with that, I'd like to move on to the next segment of our podcast, known as You Ask, We Answer. So this is where we will address questions that's been posed or we collected from our customers and partners. So the first one came from our partners when they actually stumbled onto CyberArk Labs GitHub repository. And there's a lot of things there that they couldn't quite understand. So most of the questions are going to be around stuff that we've already published. Would you like to just give a quick overview on what do we have on our or what tools do we have on our GitHub from CyberArk Labs?
Yeah, sure. So first of all, I should say that for many of our research projects, we try to produce some sort of tool or white paper, as you mentioned, to demonstrate the point or the bottom line of the research. So we have many tools under the CyberArk Labs or CyberArk repository that can be used by SOC teams or security engineers to discover an attack surface. And we have a couple of tools currently, I think about 11 or 12 tools in the repository, all covering different types and different tools for different environments, discovering or revealing an attack surface.
Thank you. So we have specific interest or question around some of these tools. The first one came in around KubiScan. Would you be able to tell us a bit more about what is KubiScan and what does it do?
Sure. So KubiScan, I think, one of our best tools we have in the repository. It is a tool that used to scan Kubernetes environment to map out role-based access control attack surface. In simple words, Kubernetes leverage role-based access control to manage authorization for users and services. It is a great way to allow dynamic access and to implement least privileged principle in that environment. But on the other hand, it is very complex to manage, and the attack surface is in some cases, because of the dynamic nature of the environment, containers come and go and pods are created and terminated. It is difficult to control and monitor the exact privileges or exact roles that each and every role, service, or user has in a certain point of time. So KubiScan is a tool created just for that, to reveal the attack surface and to allow organizations to investigate potential weaknesses in their role-based access control management. I should also say, just on a general statement, that the permission attack surface or the authorization attack surface in cloud infrastructure and in dynamic environments like Kubernetes environment is, as I mentioned, pretty complex, and this is one of the reasons we had several tools that cover the authorization and the role-based access control attack surface. But again, KubiScan is an open source tool. It's in our GitHub repository. It's written in Python, and it's pretty intuitive to use. And actually, I have here a short demo to show you. So let's have a look. Okay, so the demo here shows a few of the functionalities that KubiScan offers. So let me just run through it just to show you what we offer with KubiScan. First command that we run with KubiScan is KubiScan-RS, which shows risky users and services. And we highlighted here two service accounts, one called SA3, service account 3, and the other called Bootstrap Signer. The Bootstrap Signer is a service that is being deployed by default in every Kubernetes environment, and we can see that it is deployed under the kubesystem namespace, meaning the system and management namespace for Kubernetes. So just by looking at this table, you can have a sense of how many service accounts and user accounts you have here that you might want to pay attention to, or maybe reduce privileges or just be aware of. This is the first functionality. All right. Second functionality that I want to show you here is something called risky pods, and this is where the investigation parts comes into place. Now, those services that we listed with the RS command are deployed somewhere, and when using the -RP, the privileged pods or risky pods, we can list what pods contain those service accounts. So in other words, looking at it from the attacker's perspective, where an attacker needs to gain access to, or gain a foothold in order to compromise those service accounts. So specifically here we see a pod name called Alpine in the kubesystem namespace that hosts the service account bootstrap signer, which is privileged, as we know from the previous table. Just one more functionality, just to give you a sense of the things that you can get from this tool. This time we look at the specific privileges that the bootstrap signer service has. We use the -AARS, and now we can see that the bootstrap signer service has can get, list, and watch secrets on the kubesystem namespace. So this is the reason that we listed bootstrap signer in the first risky services table we had at the beginning of this demo. So this was just a taste of the things that the KubiScan offers. It has a lot of other functions, but I think those will be interesting the more you dig in, and the more rich environments.
Thanks, Lavi. That's a great introduction of KubiScan. And the next question was around SkyArk. I think that's also very popular download on GitHub for CyberArk Labs. Would you be able to share a bit on what is SkyArk and educate us?
Sure. So in similar nature, SkyArk covers the authorization attack surface, not in Kubernetes environments, but in cloud environments. Specifically, SkyArk covers AWS and Azure. And as I mentioned, both cloud providers, Azure and AWS, and actually any cloud provider, has some sort of identity access management module where users can create users, service accounts, and create policies and attach those policies to certain users. So there's a lot of flexibility there, and with that flexibility, there's a lot of complexity. And again, it is difficult to monitor and control this attack surface. Not to say if you're after least privilege principle and you want to implement it in your environment, it is really difficult to know what kind of permissions or API calls those services and users use generally in order to minimize their permission set they're allowed to use. So yet again, SkyArk is a tool that covers the permission attack surface, the authorization attack surface. It's an open source tool. It's written in PowerShell, and it's also pretty easy and intuitive to use. To quickly scan the environment, you just need to provide it a pretty simple read-only access to the IAM module and the logs, and it will provide you with the nice output of the risky services users. And one thing that is very interesting, which is called shadow admins. Those users, or actually I should say cloud entities, that can escalate privileges and potentially compromise or control the whole account. So let me show you how it looks like with a quick demo. All right. So here we have a Windows PowerShell terminal. We can import SkyArk to our terminal and just run scan AWS shadow admins. We are running here in AWS environment. We provide it with the access key and secret key, and we let it run. And it pretty quickly will come out with the results. I'll pause this to cover or explain what the tool has found. Here we go. We can see that the AWS Stealth module, which is the module that lists out the privileged entities and shadow admins, found 44 entities, out of which 14 are shadow admins, meaning 14 entities that you might not intended to allow them complete control of the account, but they do have complete control of the account, and you should have a look and see if it was an intended authorization or not. And it also has a nice feature covering the number of unsecured users, meaning users that do not has not deployed MFA for their console access. So this is just a quick demo of what SkyArk can do. Again, it's pretty intuitive to run. It can run on pretty extensive and large environments, showing results in just a couple of seconds or minutes if it's a large environment.
Does SkyArk only work on AWS?
AWS and Azure, those two environments.
Thank you. The two most commonly used cloud. So I'd like to ask the next question, which is around SkyWrapper. So what is SkyWrapper and what does it do?
So SkyWrapper is a pretty new tool that we published, and it covers an attack surface that I call key chaos, and I'll explain. With the transition to the cloud, short-lived tokens, temporary tokens, replace the traditional API keys for both users and services. Now, almost all authentication processes generate at the end of the process a short-lived token, and we've seen that in the Teams vulnerabilities that we discussed before. In the Teams case, the credentials that were exfiltrated or extracted and compromised by the attacker were access token generated after the user authenticated, after it has validated himself with a multi-factor authentication process. So we see those short-lived tokens everywhere. And the point is that it's much more difficult to know how many tokens, short-lived tokens, are currently live and who is using those tokens. Because in many cases, we see those tokens being used by users or services, and those users and services send those tokens as part of an OAuth authentication or other process to other service or user. So it's not necessarily the entity that created the token that is the one using it. Anyways, SkyWrapper is a tool that aims to discover this attack surface associated with the short-lived tokens, those currently live tokens, and more specifically, tokens that were generated by other tokens. So what we have in mind when we talk about short-lived tokens is a token that may live for 15 minutes, 20 minutes, maybe an hour. But in some cases, those short-lived tokens can be used to generate other privileged tokens. So generating some sort of a cycle and a persistent access for both users, services, and attackers, of course. So SkyWrapper focuses on that, on the currently live short-lived tokens and tokens that were generated by other tokens, meaning that there's something fishy here. Let me show you how it looks like. So we just it's a Python tool called the SkyWrapper, as we mentioned. It pretty quickly will scan the environment, and I'll pause it just in a few seconds to highlight a few of its findings. There we go. So first thing that it found is we see here that SkyWrapper couldn't find the IKEA token used to generate those 4 tokens. IKEA tokens are the API tokens we use to run API calls to the cloud infrastructure. Now, if SkyWrapper can't find those IKEA tokens that generated those temporary tokens, it means that those 4 tokens that we have listed here are tokens that were generated by other temporary tokens. A very fishy, process that we need to look into. So this is the cycle that I talked about before of tokens generating other tokens. And another output that SkyWrapper generates is the number of tokens that were generated by EC2 access keys. So as you probably know, cloud instances in many cases are assigned roles. So the machine itself has access to tokens. And those tokens, as we've seen in previous cloud breaches, can be used to generate other tokens and escalate privileges. So the feature that SkyWrapper covers here is targeting tokens created by EC2 access keys. So tokens that were intended for machines to use are now used to generate other tokens somewhere else. So again, this is just a taste of what SkyWrapper is all about, and it mainly focuses or provides SOC teams and security engineers visibility into the key chaos attack surface.
Thanks, Lavi. Thank you very much for coming on to our podcast.
Thank you very much. It's been a real pleasure.